All right, I'm going to say it. Logarithm, logarithm, logarithm. All right, we're going to solve exponential equations with logarithms, which are just the inverses of exponentials. Everything that we're doing in this video, we've done before. Okay, so remember when we were solving equations, maybe like this. What did we do? We isolated x cubed, and then we cubed root both sides. We isolated that function and then took the inverse function of both sides. We've done this with a bunch of things, right? Maybe we're looking at solving a square root equation. We isolated the square root, and then we took the inverse function of both sides. And we've done this with a whole bunch of different equations. Exponential equations are not going to be any different. All right? And for exponential equations, you're going to isolate the exponential, and then you're going to log both sides. Just like what we've been doing for all of your mathematical equation solving history. Right? The only difference is that the inverse function looks different now. Okay? But it shouldn't be anything too crazy. Example 2. Solve. Part A. 8 to the x minus 7th equals 1. As a side note, we could use the last video's method here, because 8 to the 0th equals 1. And we could use this to find that x equals 7. But let's show the method. The method says get the exponential function by itself. Well, exponential function is already by itself, right? The exponential function is 8 raised to the x minus 7. It's by itself. We're going to undo it by logging both sides. There's infinitely many options for what logarithm to use. Let's use the one with the same base. Log base 8 of 8 to the x minus 7 equals log base 8 of 1. And again, we choose, oh, this is step 2, right? Log both sides. We choose log base 8 because I tried to fix that 8. Because 8 is the base of the exponential. All right, and now we just simplify. The inverse property says log base 8 of 8 to something. They cancel each other out. We're just left with the exponent. And the right-hand side, we can simplify too. Log base 8 of 1 is 0. We could convert that to exponential form. 8 raised to what exponent equals 1? 8 raised to the 0th power equals 1. We could also evaluate this with a calculator, change base, but we want exact answers here. All right, so if you use a calculator, make sure you're getting exact answers. Otherwise, you're going to have to leave it as a logarithm. In other words, x is 7, and we can check our answer. Yes, 8 to the 7 minus 7th power is equal to 8 to the 0th, 1. Some of these can be a little bit messier, though, so let's get into the messy stuff. Not too messy yet, just a little bit messier. 2e to the 3x plus 1 equals 5. We had 2 steps. Well, there's more than 2 steps, but 2 of the main steps. Get the exponential function by itself, undo the exponential with a logarithm. So we want this to be by itself. We want this isolated. We're solving for e to the 3x. We're going to subtract 1 first. And again, we want this by itself, so we're going to have to divide by 2. And now we've completed that first step. Our exponential function is by itself. Now we're going to undo it with a logarithm. Now we're going to take the natural log of both sides. Why? Because the natural log of e to an exponent is going to cancel out with the inverse property. This is just 3x in the right-hand side. Right-hand side can't simplify. We could find a decimal approximation, but the problem asked for an exact answer, so we're going to leave it as natural log of 2. Divide both sides by 3 and we'll get our answer. 1/3 ln 2 is our exact answer. There's a bunch of ways of writing this answer. You could write ln 2 over 3. You could write the natural log of the cubed root of 2. I think this looks the nicest. All right. Could check our answer here. This one is actually a really good practice to check your answer, right? You look at the left-hand side. Comes 2 times e to the 3 times 1/3 ln 2 plus 1. The 3 and the 1/3 cancel, e to the ln 2. Again, these are inverse functions. E to the ln of 2 cancels to just become that exponent. 8 equals 5, just like we wanted. Good practice to do this by hand. Would highly recommend you do this as you're working through the problems. Part C is going to be pretty similar. 2e to the 3x plus 1 equals -2. Jason, why are you doing almost an identical problem? This guy, this math professor. All right, well I know how to do this. Let's subtract 1 from both sides, Jason. Just like before. Divide both sides by 2, just like before. All right, it's a little messier. Whatever. Let's take the natural log of both sides, just like before. Undo that exponential function. Do you see what I'm freaking out about? Uh-oh. Why is this a problem? Well, you type it into your calculator. You tell me what this is. You tell me what the natural log of -3/2 is. Calculator's going to get really angry. The domain of the natural log is only positive numbers. We look at the graph of the natural log. Any natural log looks like this. You can't plug in a negative into a natural log function. This is undefined. That's a problem. There is no answer here. There is no solution. I tricked you guys. It looked similar. I probably didn't trick anyone. You probably already knew. All right, Jason, what's going to happen? I know you're trying to be a weirdo. All right. And you can see this graphically, right? There's no solution. It has to do with the range of these functions. We can look at solutions to equations by graphing them, right? 2e to the 3x. Whoa. 2e to the 3x plus 1. In the previous problem, right? In the previous problem, we said, when is that equal to 5? And if we found a decimal answer, this is what our decimal answer would be. But in this problem, it's almost identical, but now we're curious, when does this equal -2? Never, right? Exponential functions, the range of an exponential function is only positive numbers. And sure, we vertically stretched this and we shifted it up, but it just never is going to cross that pink line. So watch out for that. It is possible that some of these answers are not going to have any answers. Stay on your toes. And by the way, you could figure this out when you tried to get an idea of what this answer looked like, but hopefully you can recognize that we can't take the natural log of any logarithm of a negative number. 2 to the x plus 1 equals 6 to the 2x minus 1. I hate these. I'm going to be honest with you guys. These are the worst. We want to isolate the exponential function. We have 2 exponential functions here, actually. So do we take log base 2 of both sides? Do we take log base 6 of both sides? Those are both good choices. So is the natural log. You can actually use any log. But we can use log base 2, log base 6, natural log, common log. These are the best choices. And your answer will look a little different, but they're all correct. Well, let's just choose one and get it done with and see what happens. These ones look pretty messy for an exact answer. Let's use the natural log. I love natural log. Let's take the natural log of both sides. So because we're using the natural log, nothing's canceling, right? It would only cancel if it were natural log of e to something. Inverse property from 6.5 does not apply here because we're using natural log. If we use log base 2, then one of them would cancel and the other one wouldn't. That's one argument to use log base 2 or log base 6. But natural log is also very good here. But we can still use the power rule. The power rule says that this exponent comes down in front. This exponent comes down in front. That says that x plus 1 parentheses are mandatory. The entire exponent is getting multiplied by the natural log of 2. On the right-hand side, the entire exponent is getting multiplied by the natural log of 6. And this looks messy, but I promise this is just a linear equation. Get all the x's on one side, get all the not x's on the other side, divide by that coefficient, and you can solve for x. But to get all the x's on one side, we're going to have to distribute. Gonna have to distribute on both sides. This becomes x ln2 plus 1 ln2 equals 2x ln6 minus 1 ln6. Everything with an x needs to be on one side. Everything without an x needs to be on the other side. Let's get a red side and a blue side. So if we subtract 2x ln6 from both sides, be very careful. These are not like terms. We can't combine these. Right? This is x ln2 minus 2x ln6. And the right-hand side, let's subtract ln2 from both sides. We want x to be by itself, so we're going to have to factor out that x. It looks weird, but at the foundation, what we're doing is nothing crazily new. It just looks messy. Factor out an x, because we can't combine like terms. It becomes ln of 2 minus 2 ln 6. And the right-hand side, we can simplify, right? Using properties of logarithms. This is negative ln2 plus ln6. Factor out a negative and use the product rule. 2 times 6 is 12. This is negative natural log of 12. Looks a little nicer. I'm not going to give points. I'm not going to take off points if you don't write it as natural log of 12. But it does make it look nicer. Now we can solve for x as long as we divide both sides by the thing that is getting multiplied by x. So x is negative ln 12 divided by ln 2. And we can simplify that denominator too, can't we? To combine these logarithms, we first have to get rid of that coefficient. Move that to the numerator. That exponent. This becomes the natural log of 36. Now we can keep simplifying. The negative natural log of 12. Quotient rule. Says 2 over 36. That's 1/18. Power rule again. This is why it's so important that we spend a lot of time on those properties, because I'm using a lot to clean up our answer. Negative ln 12 over negative ln 18. The negatives cancel. All right. Becomes ln 12 over ln 18. And this is where it becomes really, really important. These don't reduce in the traditional way. All right. It's 2 times 4 and 2 times 9. You can't simplify this. There's no property for this. It's going to be our final answer. Our exact answer. X is ln of 12 divided by the ln of 18. And that looks a lot cleaner than what we started with. I just moved it to right behind my head. Let's check our answer. ln 12 over ln 18. What is that approximately? About 0.8597. Let's plug that in. 2 raised to the 0.8597 plus 1. Is that equal to 6 raised to the 2 times 0.8597 minus 1? Thank goodness. Those are about equal. All right. We're good to go. That's our exact solution. And if we used a different base, our answer would look different. Whoa. If we used a different base, our answer would look different. If we use a natural log, it'll look like this. Those properties, simplifying your answer, makes things look a lot nicer. That's maybe like 1 point is that whole process. All right. Let me know if you have questions. Let's do another one. Part E. Oh, I forgot. I forgot this was in here. Y'all are not gonna be happy with me about this problem. Oh dear. As a one side note, on almost all the problems, it wants you to give an exact answer. But if it wanted you to approximate, you could approximate too. So most ask for the exact, but some ask to approximate. If you're approximating, try not to approximate until the end. All right, let's do part E. E to the 2x minus e to the x minus 132 equals 0. Part E for excellent. Y'all are gonna really like this one. Look at how much time is left in the video. This is the last. I don't know why there's so many loud cars today. This is the last problem in the video. So you know you're in for a treat. And the reason why this is a problem is we can't isolate an exponential, right? If I get e to the 2x by itself, then this is going to be on the other side. We have 2 exponential functions, but we also have a constant. We can't isolate both. We cannot solve this the same way that we did before. Try it. You'll see what happens, hopefully. Cannot isolate both exponentials. Right, and the last one, right, there was no constant, so it was possible to get a single exponential function by itself on each side. This one has 2, but it also has a constant, so we can't isolate it. So I'm not expecting you to see this trick, but I'm going to tell you that trick. We're going to do a substitution. Let u be e to the x. So replace e to the x with u. So this becomes a minus u minus 132. Oh, the right-hand side equals 0. Replace all the e to the x's with u's. What is this? Well, e to the 2x, that's e to the x squared. Multiply those exponents. And e to the x is u, so this is just u squared. So if we use this substitution, if we use this substitution, we get a quadratic equation. We can factor, we can use a quadratic formula, we can complete the square. Oh, love quadratic equations. What quadratic equations with exponential functions, with logarithms, it's all coming together in this nice, lovely soup that's so delicious. So, pick your poison. Quadratic formula is more straightforward. Because factoring this, we have to find two numbers that multiply to negative 132 that add to negative 1. 132 is pretty big. You could use a calculator and try to figure this out. But let's get some practice with quadratic formula. The solutions to this equation are u equals negative b plus or minus the square root b squared minus 4 times ac all over 2a. And then again, a is the coefficient of the squared term, b is the coefficient of the linear term, and c is the number at the end. Let's plug this in. The opposite of negative 1 is positive 1, plus or minus the square root of negative 1 squared minus 4 times 1 times negative 132 all over 2 times 1. Copy this to the next page. It's 1 plus or minus the square root. Negative 1 squared is positive 1. Multiply this other thing. The negatives cancel by 4. It's going to be 500. And this is a bad idea. 528 all over 2. All right, we should use a calculator. 4 times 132. Yeah, it's 528. That's good. Is 529 a perfect square? I sure hope so. Anyone know? 529? Is that a perfect square? Square root of 529? Thank goodness. It's 23. This problem gets really messy if it's not. If 1 plus or minus 23 over 2. And this is two answers, right? That's 1 plus 23 over 2. And 1 minus 23 over 2. And remember, this is what u equals. So 1 plus 23 is 24. 24 over 2 is 12. This becomes negative 22. Negative 11. All right, this is how it factored. We were looking for two numbers that multiplied to whatever, 132 that added to negative 1. And the opposites of these numbers are the ones that satisfy it. But why are we in green? We're in green because we did that substitution. U is e to the x. So bring this all the way over. U is e to the x. So e to the x is equal to 12, and e to the x equals negative 11. The problem's not asking us about u, the problem is asking about x. And u is the same thing as e to the x. So we can replace the u with e to the x. If two things are equal, we can replace them, no problem in math. Now, we had some questions about the domain and range of exponential functions. And you all said many times, oh, okay, the range of an exponential function, as long as there's no transforms, is only positive numbers. The range of e to the x does not include negative 11, right? When does e to the x intercept negative 11? It doesn't. Nowhere. This part's impossible. So we only have to solve the other part. When does e to the x equal 12? Take the natural log of both sides. Left-hand side, we can use the inverse property. Log base e of e to the x is just x. How does the natural log of 12 simplify? Well, it doesn't. This is our exact answer. Let's check our answer. Let's see if we did it right. All right, Desmos. The natural log of 12 is our answer. It's about 2.4849. Is e to the 2 times this answer minus e raised to the 1 of this answer minus 132. That's supposed to equal 0. Well, this is an approximation. It doesn't quite equal 0. If we actually typed in ln12, look at what happens if we type in ln12. And again, because the computer says, well, it's very close to 0, right? That's negative 0 point and then 13 zeros. Yeah, all right. There's some rounding error here with the computer side, not even our side. We're typing in the exact answer, but we have the right answer. And we're done. Now, I understand that was rough for all of you. This is the end of the video. This video is way too long. So as my little parting gift to you guys, I'm going to give you a little smiley face. Smiley face is saying, isn't chapter 6 fun? Have a great day.